Welcome back. This is my series on graphing quadratic functions. And this time we're working in standard form to start with. So our first step, as always, is to find the y-intercept. And that's really easy in this form. Again, just like in factored form, we're making the x is equal 0, but that makes this first term and the second term just disappear. And so we know that for the y-intercept, x equals 0 and y equals -12. So the best thing about standard form is, sorry, there's people popping balloons in the hallway. The best thing about standard form is that the y-intercept is super easy to find. Okay, so for step 2, we can either factor or use quadratic formula to find the x-intercepts. So I'm going to do quadratic formula because I already have videos on how to factor, and I don't think I have one on quadratic formula. So x-intercepts. Again, for this one, I can try to factor it. This does factor, or I can use quadratic formula, whichever you prefer. So I'm going to have 0 equal, right, because for the x-intercepts, y equals 0. So I'm just going to write it down again with a 0 here. And then I'm going to say a is 2, b is -5, and c is -12. It's not specifically required for you to write that, but I do think especially when you're starting out, or having a refresher, whichever, which if you're watching this video is probably the case, I do think that there's a value in writing it down, actually writing out what a, b, and c are. All right, so next I'm going to write down the quadratic formula. So quadratic formula you can remember by singing it. It goes to Pop Goes the Weasel. There are several other things it can go to as well. But Pop Goes the Weasel is pretty universally known. So x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. To help you remember it, because I think the hardest part of quadratic formula is remembering the quadratic formula. So one really important thing that I want to make sure you know is that I don't say -b here, I always say opposite b. So the other thing, so the opposite of b is 5. And then the other thing on that is, again, remember when I'm substituting stuff into a formula or into an expression, I always like to use parentheses. That's really important in this because the signs matter so much. So this is 4 times 2 times -12. All right, so when I find that, this is going to be equal to, all over 2 times 2. So this is going to be, hold on for just a sec. So this is going to be, under the square root, I'm going to have -5 squared minus 4 times 2 times -12. So that's going to be 5 plus or minus the square root of 121 over 4, which is equal to 5 plus or minus the square root of 11 over 4. So the way that you can tell that this factors is because this 121 is a perfect square. If it wasn't a perfect square, that would mean that it doesn't factor. But since it is a perfect square, it does. Oh, sorry, this should not be here. Let me just erase it really quick. There we go. It's just 11. It's not the square root of 11 anymore, right? Because if I square rooted it, it's not square rooted anymore. Okay, so now I'm going to go here and here. So I'm going to do 5 plus 11 divided by 4 and 5 minus 11 divided by 4. So 5 plus 11 is 16, divided by 4 is 4. 5 minus 11 is -6, and -6 divided by 4 is -1.5. So usually I don't change, I usually don't change mixed numbers into fractions or into mixed numbers, but when I'm plotting points, I do. All right, so there are my x-intercepts. Those are 2 of my points. Here's 1 point. All right, so step 3 is finding the axis of symmetry or the line of symmetry. They're the same thing. So 2 things. I can just find the average of these 2 numbers, right? Add them together. So 4 minus 1.5 over 2, which is going to give me 1.25. Or I can do this really cool thing where I just do 5 divided by 4, right? Because this, right, so it's this part. So the 11 over 4 just tells me about how far away from the line of symmetry my x-intercepts are. So since I don't care how far away they are when I'm finding the axis of symmetry, I can just do 5 over 4, which is 1.25. So I feel like that tends to be a little bit higher level thinking, so that might be a little bit more challenging, but if you can notice it, I feel like it's a really good time saver. Okay, and then step 4 is to find the vertex. And just like always on the vertex, we're just going to take the 1.25 and we're going to plug it into the equation. So y equals 2 times 1.25 squared minus 5 times 1.25 minus 12. And you're just going to put that into your calculator, no big deal, and you're going to get negative 15.125. So my vertex is 1.25 and negative 15.125. Cool? All right, so now we're going to make our graph. Oh yeah, so let's do our highlighting thing again. Okay. So for the x-intercept, I used quadratic formula, so that's fine. And then for my vertex, I used the 1.25 from here. I think that's really it. Okay. Oh, I guess I could do this. This is 0, and then these are 0. Okay, on to my graph. So now, again, I'm going to make my graph non-symmetric vertically because I have so many points below negative 15.25, negative 12, and I only go up to 0 is my max for y. All right, so I'm going to start by plotting my y-intercept 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16, 15, 14, 13, 12. Okay. And then I'm going to plot my 2 x-intercepts. Again, I'm going to make my axis a little bit wider here because the numbers are smaller and it will help me see better. So those are my 2 x-intercepts, positive 4 and negative 1.5. And then my axis of symmetry is going to be at about 1.25. And again, we dash that in to show that it's not really part of the graph. And then on this line, I'm going to go down to negative 15.25, which is going to be right about there. Okay, so this distance, I'm going to sketch it in and then I'm going to erase it. This distance here is 1.25. Right? Because it's the distance between 0 and my axis of symmetry, which means I want to go 1.25 on the other side, which is at about 2.5 to reflect it over here. All right, so now I'm going to fill in all my points. So this one is negative 1.50. This one is 0, negative 12. This one is negative 1.25. Negative 15.125, barely fit it. This one is, what did I say, 2.5, negative 12. And then this one is 4, 0. And again, to get this number, I just multiply my axis or line of symmetry by 2. And then I'm going to sketch my parabola. That's it. All right, so again, steps: find the y-intercept, find the x-intercepts, either by factoring or by quadratic formula. Find the average of the 2 x-intercepts, either using the negative b over 2a, the part of the quadratic formula that's not under the square root, or by just adding the two x-intercepts together and dividing by 2. And then I found the vertex by plugging the line of symmetry into the original equation for x. All right, and then plot and make your graph. That's it.